Today's lesson is 7-3, and it's over proving that a quadrilateral is a parallelogram. So here is just the basis of what we're going to learn and the vocabulary. We're going to go over like a diagonal and be talking about a parallelogram. Okay, we have quite a few theorems in this one that we need to go over to prove that it is a parallelogram. So the first one says that parallelogram, it's called parallelogram opposite sides converse. Okay, what it's basically telling us is that the opposite sides of the parallelogram, opposite we mean, the ones directly across, like AB is going to be congruent to CD. We also know that if it's opposite sides that BC will be congruent to AD. And we know by the little tick marks that we put, the twos go together, so those two sides are congruent, and those two sides are congruent. The next one we have is parallelogram opposite angles converse. So same thing with our opposite angles. We're talking about angle A and angle C. They are congruent. And angle B and angle D are congruent to each other. Okay, here's an example of using that to prove that it's a parallelogram. Okay, and it says, for what values of x and y is a quadrilateral, and I'm sorry, I cut the L off, quadrilateral STUV a parallelogram. Okay, going back on the theorems we just talked about, what do we know about the opposite sides? The opposite sides are supposed to be congruent, is what we just went through. So, this side and this side should be congruent, and these two would be congruent. So there's my little tick marks. So if that is true, we need to go over here and find where we have either two x's or two y's. And this has a y and an x, looking at those two. So we're not going to use that for an equation, but these two right here both contain x's in their expression. So we're going to go ahead and use those two. So what do we know? We know that we just said that they were congruent. So we are going to set them equal to solve for x. So we have 24 minus x is going to equal x plus 6. With that being said, then we're going to go ahead and combine our x's, move our x's to one side so that we can get them together. And we would get 2x plus 6 equals 24. Then we're going to go ahead and move our our 6 to the other side. Okay, and when we do that, we're going to get 18 equals 2x, and the last step's to divide. So we're going to get that x is equal to 9. Okay, so we have x is equal to 9. We still need to find the value of y. You can go ahead and take that 9 and plug it into the equation up top. So we're going to go 2 times our 9 plus 3. 2 times 9 is 18, and 18 plus 3 would give us 21. So that means this top up here must be 21, and I'm going to erase part of this to get rid of those circles so we can see what is going on. So we know that this top side up here must be 21. If that is true, this is y. This whole thing down here is y. So our y must be 21. So this is a parallelogram when we have the values of x being 9 and our y being 21. Okay, we have two more theorems now. First one says that opposite sides parallel and congruent theorem. And that is saying that not only are the opposite sides congruent, but the opposite sides would also be parallel. No, it's not saying both sets of opposite sides. In this one, it's just saying one pair of opposite sides of a quadrilateral are congruent. and parallel, then we can prove it is a parallelogram. But we know from the other one that the other opposite sides are also going to be congruent. But that's the other theorem, and they do get mixed together when it is a parallelogram. Okay, and the last one we're going to talk about is that the parallelogram's diagonals are converse. Okay, diagonals. Some of y'all, that might be a new word, but the diagonals are going across the parallelogram on the inside to make an X on the inside. Those two lines would be the diagonals. So that's what we're talking about there, is those lines being the diagonals. So let's go and think about and see what this theorem is really saying. It says right here, if the diagonals of a quadrilateral bisect each other, and we know bisect means it's cutting both sides, and it's cutting the sides in half, so we have two equal parts of that line, then the quadrilateral is a parallelogram. So in other words, these diagonals, both of them are bisecting each other. So when BD gets bisected by AC, these two sides would be congruent. And on the flip side, since they're both bisecting each other, BD is also bisecting the AC, which in return makes these two sides also congruent. Let's go and do a couple examples off those. Okay, first one, for what values of X is quadrilateral CDEF a parallelogram? Okay, we just did the one that talks about the diagonals that bisect each other. The theorem, we just worked with that theorem. So what do we know? They already told us that these two diagonals are congruent, so we know that in return these also must be congruent, which means for our equation we would set these two equal. We're going to have 5x minus 8 is going to equal 3x. Okay, so I'm going to go ahead and move my 5x to the other side, and I'm going to subtract and get a negative 2x. Okay, so I know that when I go ahead and divide, I'm going to get x is equal to 4. I don't have to plug it in and do anything else. That ends up being our answer because it wanted to know what value of x would work in this to make it a parallelogram. Okay, then the next ones, they ask us to state the theorem we can use to show that the quadrilateral is a parallelogram. So let's see what's going on in number 3. They're telling us by the arrows that these are parallel. So we know that they are parallel and they're both 30 meters. So they're also congruent. So we can go back and look at the theorems that we talked about earlier, and it would go with the opposite, and it's hard to write on here, sorry, opposite sides, parallel, and congruent theorem. Okay, so that's the answer for number 3. Let's go and look at number 4. And I'm just going to erase this so it's not on the screen. We don't have to even see it. Okay, so we're looking at number 4. Let's go see what's going on with our information on number 4. So they tell us that these opposite sides are both 7 inches. So we can go ahead and mark it with the tick marks. And the other sides are 5. So we know right there that our opposite sides are congruent. So we're going to go back into the parallelogram, opposite sides converse. And I'm abbreviating. Opposite sides converse theorem. So number 4 is going to go with the parallelogram opposite sides converse theorem. Oops, I thought I was on the eraser. Let's go back over here to the eraser so we can do number 5. Okay, number 5 shows us that our opposite angles are congruent. So that would be the parallelogram opposite angles converse theorem. Angles And I'm running out of room. Converse, C-O-N, if it doesn't, can't see it on the screen. Converse theorem is the one that is going to go with number 5. Okay, we've talked about quite a few things that would help us prove a quadrilateral is a parallelogram. So this page right here is pretty important because this page goes ahead and it's the summary of all this stuff. The summary, it's where we have all the theorems together and for the ways to prove that a quadrilateral is a parallelogram. So we've got from definition, show that both pairs of opposite sides are parallel. We've got show that both pairs of opposite sides are congruent. We've got show that both pairs of opposite angles are congruent. Show that one pair of opposite sides are congruent and parallel. So it's got that and parallel. And then the 5, show that the diagonals bisect each other. So we have these 5 ways on this summary sheet to prove that a quadrilateral is a parallelogram.